Okay, so welcome to the course. We'll start with the definition of derivative. What is a derivative? Well, there are basically two definitions of derivative based on what we mean or what concept we are using it. So the physical sense of derivative is rate of change, which we are not very concerned with. However, the mathematical sense of it, the definition of derivative is the slope of the tangent line of a function at any point. Any function that we have will create a graph, and the slope of this graph is the derivative. So what do I mean by this exactly? So imagine you have a graph like this. We can represent this by a function and an equation. So at any point, the tangent line or the slope of the tangent line to that point, that is called the derivative. So basically, when you have an equation, when you find the derivative of that equation, what you are doing actually, you are finding the slope at any point of that function. So you are finding the slope here, here, here at any point of the function. That is the derivative, and that is basically the definition of derivative in the mathematical sense of it. It is the slope of a tangent line at any point to a function. And if we talk about the physical sense of derivative, sometimes it is used to find the rate of change. Imagine you have on this axis you have time, and on this axis you have distance. So basically, if you get any points, it will be velocity. You'll get a graph, and the slope of that graph, that is basically the derivative. So we can use derivatives in finding rate of change in the physical world, or in the mathematical sense of it, it is the slope of a tangent line at any point. So let's say we will get an equation like this: 3x squared plus 1 times the square root of x. This is basically an equation, and it has a graph. How can you find the slope at any point? Well, there are rules, and that's what we are going to talk about in the next lectures. We will not be using the definition of derivative, which contains limits and a lot of complicated stuff. We will not be using that in order to find the slope of this function at any point. However, we will be using shortcuts in order to find the derivative of any function that we want. So this is the topic of this section. We'll be talking about the rules of derivatives, or the shortcuts to find derivatives of any function. Concerning notations, we will be using these different notations. So the first one is, this is the most common, is f. Let's say we have a function. The derivative of it is f prime. So let's say we have f of x equaling x squared. When we want to find the derivative, or we want to express the derivative, we basically say f prime of x squared. We will put the function right here. So the first notation is the prime. All we will have d over dx. If we are differentiating in respect of x, if we are differentiating in respect of y, we basically say d over dy. And we sometimes use this notation d of f of x, which basically means the derivative. So this is a short definition of derivative in the mathematical sense, which is the slope of the tangent line at any point to a function or to a graph. That is the derivative. And in the following lectures, we will look at the rules and the shortcuts that let us find the derivative of any function. So let's check out the first rule.